Hello everyone, my name is Mano Dattatreya Wadikar. Today's topic is means Style Generative Advisor Network. Starting with first point. The first point is Generative Advisor Network. Generative Advisor Network was proposed in 2014. Since it is the inception, there are lot of improvements are proposed which made it state of the art. The method generates synthetic data including synthetic images. However, most of these improvements made on the discriminator part of the model, which refine the generation ability of generator. This also implies that there was not much focus on generator part, which caused the lack of control over the generator part of Gen. There are some parameters that can be changed during the generation part, such as background, foreground, and style, or also for human face. There are many features that can be altered in the generation of the various images, such pose, hair color, eyes color, etc. The second point, according to the second point, is StyleGAN propose a lot of change in the generator part. The StyleGAN propose a lot of change in the generator part, which allows it to generate the photorealistic high quality images as well as modify some part of the generator part. So moving to the next slide, as you can see, this is the architecture. Architecture includes the StyleGAN uses baseline progressive GAN architecture and proposed some changes in the generator part of it. However, the discriminator architecture is quite similar to the baseline progression. Let's look this architecture change one by one. So when we go to one by architecture, so first point is baseline progressive growing GAN. The StyleGAN uses the baseline progressive GAN architecture, which means that size of the generator images increases gradually from very low resolution to the high resolution. This is done by adding a new block to the both the model to support the larger resolution after fitting the model on the smaller resolution to make it more stable. So the second part is the bilinear sampling. The author of paper uses bilinear sampling instead of nearest neighbor up-down sampling, which was used in previous baseline progression GAN architecture. In both generator and discriminator, they implemented this bilinear sampling by low passes, filtering the activation with the separable second order binomial filter after each of the upsampling layer and before each of the downsampling layer. So next part is the mapping network and style network. The goal of the mapping network is to generate the input latent vector into intermediate vector whose difference elements control different visual features. Instead of directly providing latent vector to input layer, the mapping is used in this paper. The latent vector of the size 512 is mapped to the another vector of 512. The mapping function is implemented using 8-layer MLP. 8 fully connected layers. The out of mapping network, when W is passed through the learner affine transformation before passing into the synthetic network, which is adaptive instance normalization module, this model converts the encoded mapping into the generated image. And the next part is removing traditional inputs. The most previous style transform model uses the random input to create the initial latent code of the generator. The input of the 4x4 level, however, the StyleGAN author couldn't that the image generation features are controlled by the ADL. Therefore, they replace their input and initial input with the constant matrix of 4x4 by 512. This also contributes the increase in the performance of the network. The next point is the addition of noisy input. A Gaussian noisy is added to each these activation maps before the operations. A different sample of noises is generated for each block and it is interpreted on the basis of scaling factor of that layer. And the last part is the maximum regularization. The style generation used in intermediate vector at each level synthesize network which may cause a network to learn correlation between different levels. In order to reduce the correlation, the model randomly select two input vectors Z1 and Z2 and generate the intermediate vectors W and W2. For them, it then the trains sum of the level with the first switches. To the other train, the rest of the levels which switch in random split points ensure that network doesn't learn correlation very much. So this is the style on the basic of resolution. And next point is, in order to have more control on the style of the generation image, the synthetic network provides control over the style to the different level of details. These different levels are defined as, first point, there is a Coursera, which is resolution of 4 by 4 and 8 by 8 affect both general hairstyle, face shape, etc. The middle resolution of 16 by 16, 32 by 32 affect the finer facial features, hairstyle, eyes, open, close, etc. And last is fine, which is resolution of 64 by 64 and 1024 by 1024 affect the color of eye, hair and skin and micro features. The author of this paper also varied noise between these levels. This noise will take over the control of the change in the style these level. For the example, noise in the Coursera level cause the change in a broader structure, while in fine level cause changes in the detail of the image. The feature distance element studies according to the slide. So the aim of this feature is to study the measure the variation feature separation. In this paper, author present two separate metrics of for each distance. So the equation is on the slide. So where the Z1 and Z2 and the is a generator and evaluates the distance between the resulting images. So next part is advantages. So first advantage is high quality image generation. So StyleGAN produce an images with remarkable realism and details. Surpassing the previous generative models, it is ability to create high resolution image with the fine details, make it suitable for various applications, including art generation, images editing, and virtual content creation. The second advantage is control over image attributes. The StyleGAN allows user to control specific attributes of generated images such as age, gender, facial expression, and hairstyle. This level of control enables the customization and manipulation of the generator content, making it suitable for the creative projects and image ending tasks. The next advantage is improved diversity and variation. Unlike earlier GAN model, the style GAN generate diverse and varied images even with the same category or class. This diversity is achieved by the different accepts of image generation, resulting in wider range of possible output. The next advantage is preservation of semantic information. The style GAN maintains the semantic consistency in the generated images, ensuring that the change made to one aspect of the image do not affect other meaningful features. This helps in preserving the identity and structure of the generated content. The next advantage is the progressive training methodology. The style GAN implies a progressive training approach where it gradually increases the complexity of generated image during training. This method facilitates stable training and allows for generation of high resolution images without compromising quality. The next advantage is interpolation and morphing. The style GAN enables the smooth interpolation between the vectors, allowing for the seamless morphing between different images. This feature has application in creating realistic animations, facial expression, manipulation, and generating translation effect in videos. The next advantage is applicability across domain. The StyleGAN's architecture is not limited to specific domain and can be applied to various types of data beyond images, such as audio, video, 3D models. This makes a valuable tool for generating content in multiple creative fields. And the last advantage is the open source implementation. The StyleGAN is available as an open source project, allowing researchers and developments to explore its architecture, they customize it for specific tasks and contribute to its further development. This fosters collaboration and innovation within the machine learning community. These are the advantages. For limitations, the first limitation of this algorithm is first the training data dependency. The style gen performance heavily relies on the quality and the diversity of the training data. If the data set is biased or lack diversity, the generator images may inherit these shortcomings, leading to issues such as understanding the certain demographic or overcoming and specific characteristics. The next limitation is computational resources requirement. The training style GAN model, especially for high resolution images generation, demands a significant resources, including powerful GPUs and extensive training time. This can limit accessibility for researcher and developer with limited resource. The handling wider spread adoption and experimentation. The next limitation is mode collapse. The likely many other generative models style GAN is a successfully to mode collapse where the generator produces limited variations of image or focuses on the subset of the features while neglecting other. This can result in lack of diversity in generated images, especially when dealing with a complex dataset. The next limitation is the difficulty in interpretability. Understanding and interpreting the internal mechanism of the style GAN model can be challenging due to their complex architecture and latent space representation. This lack of interpretability may impede the ability to diagnose and address the issue during training for fine-tuning stages. The next limitation is limited control over specific attributes. While StyleGAN offers a control over a certain attributes of generating images such as age, gender, and facial expression, achieving the precise control over more specific features can be challenging. Fine generator attributes manipulating many require additional post processing techniques or domain specific knowledges. The next limitation is ethical consideration. The potential issue of the style generator content for a descriptive or malicious purpose raises ethical concerns. The generated images could be used for creating deep fake news, or affecting the social media. The highlighting the importance of the responsible development and developer of such technologies. The next limitation is generalization to the other data type. While StyleGAN has demonstrated success in generating realistic images, it applicable to the other data types, such as text, audio, or 3D models, may be limited. Adapting the architecture and training methodology for these domains can be challenging and may require significant modification. And the last limitation is continuational improvement and maintenance. As with many machines learning models, style GAN requires control improvement and maintenance to stay relevant and efficient. Keeping up with advancement in the field, addressing emergency challenges, and optimization performance for new tasks can be resource intensive and time consuming. And the last slide is about the applications. So the first application is artistic content creation. The style GAN can be used to generate novel, visually appealing artwork ranging from digital painting to several landscapes. Artists and designers leverage style GAN to explore creative possibilities and procedure unique pieces of art. The next is photorealistic image synthesis. The style GAN can be generated photorealistic images of human face, animal, object, and scenes. This capability finds application in industries such as advertising, entertainment, virtual reality, where realistic visuals are crucial for engaging audience. The next application is image editing and manipulation. The style GN enables user to edit and manipulate generated image by controlling specific attributes such as age, gender, facial expression, and hairstyle. This functionality is valuable for applications like virtual try-on, character customization in games, and digital image retouching. The next is data augmentation. StyleGAN can be augment training data set by generating synthetic images that resemble real data sample. The data augmentation improves the robustness of the generalization of machine learning model across various tasks, including object recognition, image classification, and segmentation. The last is the fifth is fashion and appeal design. The style gen can be generated fashion images showcasing clothing items, accessories, and outfit combinations. The fashion designers, retailers, and e-commerce platform users, style gen can be creative virtual fashion catalogs, visually designed concepts, and personalized shopping experience. The face generation for identity protection. The style gen can be generate synthetic faces or privacy protection purpose, replacing the sensitive information such as face or identities in the dataset used for the research of training machine learning models. This approach helps preserve and confidentiality while maintaining the data utility. The content creating for games and animations. The StyleGAN facilitates the generation of diverse character, environments, and pro videos games, animations, virtual simulation. Game developers and animators leverage the StyleGAN to streamline content creation, workflow, and enhance the visual quality of their production. The architectural visualization. The StyleGAN can be generate realistic architecture, rendering, interior design, and urban landscape architectures, urban planners, and real estate developers. It can be used as StyleGAN visualization design concept. Showcase the property of lighting, rigging, and modeling, and create an immersive virtual tour for the client. The historical and cultural heritage preservation. The StyleGAN can be historically artifact landmarks and cultural heritage based on an available reference images and the data. These applications help preserve and safely design architecture or cultural heritage for a future generation and also educational purpose. And the last is the creative exploration and research. The StyleGAN serves as a valuable tool for research enthusiasts and hobbyists to the explorer generating modeling techniques, experiments with novel ideas, and advance the state of the art in the artificial intelligence, computer vision, and compulsory creativity. Thank you.